accidentally we got this slot available, and I thought it fit that since now the facilities for video recording are now available, I thought that one, what we can say, key issue which can be understood by all if just small efforts are made, be addressed in an elaborate manner. And since now the recording is available, we should not waste the time for absent students to come. Hopefully they will go. It's on, no?
Yes, sir.
Hopefully they will view it at a later time which is suitable for them. As yesterday we had gone for very fundamentals of multi-resolution analysis, I hope that in the first instance only you might have understood to a large extent, but if you look it once again on the video, more contents will be clarified. Similarly today, this particular small slot of 45 minutes for which the recording is available, and the time is also available to the same amount, I shall try to present before you the oversimplified contents of the discrete Fourier transform. Even though discrete Fourier transform happens to be part of the syllabus and students very meticulously study for the same, what my observation has been is the perception which an individual must have for discrete Fourier transform is not appropriate. When I say perception, let us be very clear that if something is told in the class during your school days, 2 plus 3 equal to 5, I find that almost all the students mean when they read the equation 2 plus 3 equal to 5. The clarity with which the understanding of an individual about the equation 2 plus 3 equal to 5, or in a more advanced stage in algebra, we can have a plus b equal to c. I want understanding of an individual about discrete Fourier transform to that extent. Whatever may be the purpose of those people who have found out that there can be processing of the signal in discrete manner leading further to digital, but what I see is most of the times we find that some concepts which are very difficult to be understood in continuous domain, their discretized version can be understood very easily because it provides us something into a finite numbers and which are countable, and because of that we may get a good understanding. So with that simple thing in mind, I thought that rather than going into the details of first a continuous time signal and its continuous Fourier transform, then a discrete time signal like xn and its continuous transform like dtft, our attempt to relate or map from continuous time signal to discrete time signal, and right from continuous time Fourier transform to discrete Fourier transform. One may find it difficult to understand discrete Fourier transform starting from the very basics like continuous signal and continuous Fourier transform. However, in today's session, we try to understand discrete Fourier transform as an independent entity, and I am very much sure that with the things which we are presenting, it should make your understanding simpler. Let us try to restrict ourselves during the discussion. Whether the restriction is valid or not, right now let us not question that, because if we do not impose the restrictions, then it is likely that there may be many situations wherein we may be required to stretch ourselves, and there will not be any end to this stretching. So as our understanding and discussion remains focused, let us try to restrict ourselves not to go beyond these oversimplified assumptions. I do not claim minus j 2 pi upon capital N, which is now 16. Which is now 16. Is it clear now? So this minus j 2 pi by 16 will be becoming e raised to minus j pi upon 8. E raised to minus j pi upon 8. Right? So e raised to minus j pi upon 8 is one two-dimensional number. We try to understand it to the extent possible by stretching ourselves to our own elastic limit. So e raised to minus j 2 pi upon 16 leading to e raised to minus j pi by 8. So e raised to minus j pi by 8, how it can be shown? It can be shown in a simple way. Now, e raised to minus j pi by 8 means it is having magnitude 1 and angle of minus pi by 8 with the real axis or x-axis. Clear now? So I can simplify it to this value here. And this particular thing, just for representation simplicity, is called as capital W 16 now, right? Capital W 16. It is just a representation simplicity, but we should know what it is. So I have seen many students who do not at all know what we mean by Wn, but still they are able to solve the entire problem of DFT, IDFT and all that. So WAN, or for that matter W16, is one number on the unit circle. One number on the unit circle as shown here. Right? And now what is being happening? We are having, it is getting indexed by N and K, and with both N and K being integers, with both N and K being integers, Wn or W16 raised to any integer would be one point which can take the 16 positions like this. Always it can take one of those 16 positions. That's all. We do not expect anybody to understand the complex number theory in detail. That we do not expect now. We expect a very simple representation that W16 is one point in the 2D plane with magnitude equal to 1, that is on the unit circle, and when it is being raised by an integer number, it can occupy itself to any one of these 16 positions. That's all. Discrete Fourier transform is an analysis. Analysis means what? Signal we have, we are trying to find out some additional information about the signal by finding its transform. So what we are doing, and obviously xk and k will range again from 0 to 15. K will again range from 0 to 15. So xn, for n equal to 0 to 15, I have 16 numbers, and xk I have 16 more numbers. There is a distinct disadvantage of the lecture being videographed. The disadvantage is that since everybody is sure that this being videographed and would be available later, then one may decide not to pay attention when it is being live and use that time for some other purpose, and then if it is come to know that the lecture is good, then spend the time to listen and view the lecture. Otherwise, don't waste the time. But this approach is not an appropriate approach, because we are not supposed to be so busy in some other task. So I once again expect that this being a very fundamental issue of an electronics engineering student, you listen it very carefully. So what do we do now? We try to find out xk for a particular value of k based on all values of n, xn. See, how we are proceeding, that also should be very well known. We are finding out the value of xk for a particular k from all values of xn. So, effect of all values of xn in a particular manner is reflected in every xk. The manner in which it is reflected changes for the values of k. So for k, I again request everybody that, hoping that they have not understood, it's not a good hope, they will understand now very clearly. For a given value of k, capital Xk is the accumulation of all xn's in a particular manner, or for that matter we can say it is a weighted sum, not average, because we are not dividing. So capital Xk is a weighted sum of all xn's the weights differ from k to k, means for various values of k, the weights differ, xn's are same. Is it clear? So, and what is the weight now? The weight itself is a two-dimensional quantity. Xn, even though can be a two-dimensional quantity, since it is a real signal, since it has come from the samples of a realizable signal, this is expected to be one-dimensional. So, the weighted sum is just what we can say, the scaled versions of the Wn or W16 raised to Kn or Nk, that is what we will have for every Xn. We will multiply by sum of the numbers in this. Small xn will get a multiplier. Small xn will get a multiplier, and that would be the component in the sum. Xn multiplied by one of these points. When we multiply small xn by one of these points, it is very clear that that multiplication will lie where? We have presumed now for simplicity, at initial stage that small xn is real. When small xn is real, multiplying of small xn by one of these numbers will locate small xn into that number, that product, where it will locate it? Where? Nowhere. It would be a two-dimensional plane is an obvious answer. But it will... So, there would be a subspace of this 2D plane where this will be located, and since xn is real, multiplying a two-dimensional number by a real number.
The same two-dimensional number weighted was
Right.
with the real.
So multiplying a complex number by a real number leads to a complex number whose magnitude is different but direction is same. So that will be always somewhere on these lines. There would be 8 lines now, because this on the reverse side. So there would be 8 lines passing through origin, and the products will lie anywhere on those lines, and they will be summed up. They will be summed up to get x. Is it clear now? So we can go sample for various values of k. So let us have a simple value first. X0. What would be X0? Since k is 0, this
summation of all xn.
or it is k. Why is k? Because k is fixed and n we index. K is fixed and n we index. It's important. So since k is 0, this would be 0 and there this would be 1, and because of that straight away the multiplier is 1. The multiplier being 1, we are getting xn as it is. So capital X0 happens to be just the sum of small xn's. Capital X0 is just the sum of all xn's, or we can say it is capital N times the mean of the signal, average of the signal. So capital X0 provides us an indication about the average of the signal. So it simply reduces to summation of n equal to 0 to 15 xn. Is it clear? I think there should not be any doubt. Capital X0 provides me the direct information about the average of the signal. So it is DC component in the signal. It is about DC component in the signal with some multiplier. That's not right now important. But the things start interesting when we go for finding out X1 k equal to 1. So we put that value here. So what happens now? That k is 1. So W16 is here. So now look at, I would like to invite the attention of those who are not attending, that now what I am doing, now look at the term inside the summation, xn W16 raised to n means what I am doing. As stated, every capital Xk is the weighted sum of xn's. What the weights are is the question now. And now the weights are W16 raised to n means what? There would be, for n equal to 0, what would be Wn raised to W16 raised to n? So I am multiplying xn by 1 means I would be getting this would be x of 0 at distance x0, correct? Now x1 W16 raised to 1 means what? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this would be
X of 15.
right? And I am adding what? This plus this plus this. So just now have x is what we are talking about now. The partial sums, these terms in the summation are shown here. There are 16 terms. They cancel out on axis cancellation. Now, one simple thing we can conclude very easily, that if x0 and x8 are same, then that will cancel each other. If x1 and x9 are same, then we cancel out each other. And if they are more different, the summation will lead to a large value. Summation will lead to a large value. So that provides me the information about what I have come to conclusion very immediately is x0 and x8. The variation or similarity in the signal as regards to the samples x0 and x8 means I am looking at x0 and x8 together. Why they come together? They come together because I multiply x0 by 1 and x8 by -1. So I am looking at x0 minus x8. I am looking at x0 minus x8. I am looking at x1 minus x9 into something. Because into this thing actually. It is one here. So I can say that this sum remains x0 minus x8 into 1 plus x1 minus x9 into something plus x2 minus x10 into something and so on. So essentially I am doing a subtraction. So I am trying to find out that if that subtraction is more or the subtraction is less, that will give you some indication about now the sample here and the sample 8 samples away. I am trying to, what I can say, correlate. I am trying to correlate the sample now and sample 8 samples apart. So let us have this partial understanding right now here, because we have to go further, means we can't, since xk together for values of k equal to 0 to 15 tells you what is DFT. Once everything is becoming available before us, we can very easily correlate these partial knowledges. So when k is equal to 2, what happens? When k is equal to 2, what happens? Not same. When k is equal to 2, when k is equal to 2, I get this as W8, W16 raised to 2 raised to n. W16 raised to 2 is actually W8. That is W16 raised to 2, I get this. I get this. So small x0, W16 is to 0 only, because for that 0 there is no change. So this small x0 into W16 is to 0, we get same. But next, small x1 into W16 is to 1, you get something in this direction. Now see, just it will be so interesting, and you will get something here. This is the partial product. Right? Then x2 into W16 raised to 4. This was x1, W16 raised to 2, or W8 raised to 1 then, for that matter. Then x2, W16 raised to 4, you get something here. Now, that will give you a very easy indication that since that 2 has come inside, W16 raised to 2 has taken place, for indexing of n, we will be getting only 8 distinct terms. For indexing of n, we will be getting only 8. Why? Because These will never come now. W16 raised to 0, W16 raised to 2, W16 raised to 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 28, 30, sorry, 30 and 30. Or somewhere we go here in counting. So what we find, which is more interesting now, that I get x2 into this, right? Then for x4, sorry, x3 maps here, x4 maps here, x5 maps here, then what maps here? x6. Then x8. So x6, x7, x8. Remember now what is mapping? x0 is already mapped. x2, sorry, x1, x2, x3, x4 is mapped on this side. Then again I am mapping x8, 9, 10, 11, 12. So what I get x0 plus x8 minus x4 plus x12 into something. So now what I am doing? x0 plus x8 means previously when I was finding capital X1, that time x0 minus x8 was giving me some information. Now it is x0 plus x8 and x4 plus x12, the difference of these two, right? And ultimately again you will end up with what? That will be direct cancellations. So when direct cancellations take place, what do we mean by direct cancellations? This will cancel, this will cancel. So only I will be remaining with this, everything on this. On the others will have cancelled. So there would be 8 numbers. So when 8 numbers we do have, what will happen? Then I can have components of each and whether they mutually cancel. How they can cancel? Suppose if I get something here and if I get something here and something here, their y components are to cancel. Sorry, their x components to cancel and y components are to add. So ultimately I get one 2D number. That is sure. For everything I get one 2-dimensional number, that is very much clear. Now further. So when we take x3, what will happen? When we take x3, it would have gone for omega cube. It means what? That is omega 16 raised to 3 means I would have gone for this one. So this I get, these two and this I get, I skip these two, this I get. So how many repetitions are there? When the repetitions are there, I get this. First I get this, then I get this, then I get this, then I get this. Then this, then what? There is no repetition as such. We cover all. We cover all because it is not 2 to the power. Then for x4 we cover only 4. 1 we have 1, 2. For x8 we cover only 2. This and this. So with that, the idea should be very clear that I am getting a weighted sum. I am getting a weighted sum, and thus I will get 16 different such sums. Capital Xk's for various values of k ranging between 0 to 15 will give me, so what Xk's are? Xk's, so that should be very much clear. No confusion, no prerequisite required. So a lecture is supposed to be good one if not much prerequisite is required. So what are Xk's? Xk's are two-dimensional weighted sums of Xn's where weights vary for different values of k. At least everything, this thing is clear with everybody? Xk's are weighted sums. Xk's are weighted sums. Then what the Xk's represent actually? What the Xk's represent actually? These are two-dimensional values. These are two-dimensional values. So there may be a confusion about what is a significance of a particular value of Xk. Particular value of Xk, less or more, real or imaginary or complex. What does it signify to me? Are you getting me? The big question is, you can be very much expert in finding DFT because it's a simple mathematical manipulation, number crunching. But,
Yes, sir, 1 minute is remaining.
But what is to be done with that? What different Xk's correspond to must be very neatly and appropriately understood. Then, for that matter, we can very easily say that Xk can have a large value, a small value, but now since Xk is two-dimensional, Xk can also have a position, not only value. When we are having 1D, when we were stating the value, it was either away in one side or away on the other side. But when it is 2D, only value is not enough. So where it is located? So the task before us is to interpret about the significance of Xk. I think computation everybody has understood now. It is weighted sum of all Xn's with weights varying as per k. Okay? So now let us proceed for, let us wait whether how much effort is there and then proceed.